Okay, any questions on what we did on Tuesday? Okay, just to remind you, next week we are not going to have any lectures. You are going to have an exam on Tuesday 5:40, and I think I will have the exam in the department. Okay? So it means that I should reserve the room. What was the name? What was the number? 322? 322. Okay. Okay, today I'm going to talk about a paper which is interesting in a number of aspects. It is not a very, well, it is nice because what it does is, this is, by the way, the paper by Rangan and Jaikumar. And I think it goes back all the way to 1991 or 1990. Now, the nice thing about this paper is that there is an enormous understanding of how the distribution system operates. And they are not only concerned with how to operationally decide on certain issues, but at the same time decide on the system structure as well. So remember, we are drawing the figures for distribution systems quite frequently. And in this system that they analyze the following structure. So here you have a manufacturer, and here you have a warehouse, and then you have the retailer, where the customer demand actually comes to the retailer. Now, the typical question is that the manufacturer is not concerned at this point with the customer demand, but with the quantities that they sell to the retailer. So this paper doesn't have the supply chain outlook that we are trying to give, because we really want to analyze everything in a certain perspective. But we are much more concerned with selling to the retailer. Now, if the manufacturer uses traditional distribution structures, it means that they are going to ship the items to the warehouse or to the distributor. I think they call it a distributor, or wholesaler. Okay, so this is the wholesaler. So let me use the same notation or the same wording. So this is the wholesaler. And traditionally, the manufacturer is going to ship the items to the wholesaler, and the wholesaler is going to ship the items to the retailer. And this is the traditional way of operating. So that in this structure of operation, what happens is that the manufacturer usually gives a rebate or gives some kind of a discount to the wholesaler, which is called a trade discount. Now, trade discount is a discount which is given over all the quantity, over all the items that you sell. So it is not a discount that you give per item, but it's a discount that you give over all the volume that you have a transaction with the other party. In other words, this trade discount is traditionally given, and if you are a warehouse or a wholesaler who is working very frequently with the same manufacturer, you're going to have a larger discount. Okay. Now, on the other hand, wholesalers have some kind of a rebate structure with the retailers, but that part is not the part that we will be interested. We are going to have the manufacturer's perspective in this problem. So manufacturer is trying to set up a certain distribution structure, and question is, this is the traditional way of operating the distribution system. Now, will it be possible for the manufacturer to directly ship the retailer? Now, of course, in that case, there will be some disadvantages that we are seeing throughout the semester. What are the disadvantages for the retailer? Probably the lead time is going to be longer, so the retailer is going to keep more stock for that. But still, if you look at from the manufacturer's perspective, manufacturer may say the following, well, if I can give a rebate, this is called a rebate. Rebate means simply you have a certain volume of transactions, you pay some kind of a money, and then rebate means that you get 10% off after everything, all the transactions are completed. So rebate is a kind of discount, but I think the word usually is used when a retailer is in action. Okay? So it is kind of a discount overall the volume. So it's the same idea, but it's called rebate. Rebate meaning that it is given from the total of the transactions. Now, of course, rebate can be decided on the item basis. It's not like the trade discount in that sense, but we are going to see that the way that we are going to use rebate in this paper is exactly the same as trade discount. So what the manufacturer would do is to give some rebate to the retailer if the retailer accepts the fact that there will be direct shipment. So we have a design problem here. Design problem is basically which retailers are we going to have direct shipment, which of the wholesalers are we going to, well, for which retailers are we going to use wholesaler? So there's some kind of a structural decision. But at the same time, this decision is supported with some operational decisions. What should be the rebate percentage that I should give so that I will be able to persuade the retailers to work with me? So this is the problem that they are solving. So the quality of the problem that is solved is probably not as high as the quality of the problem solved for supply chain ideas. Because basically in supply chain, what do? We usually have the systems perspective, okay? And we try to solve everything in the benefit of nobody actually, but the total. We try to increase the total, and then we try to find ways of imposing this result to different parties by giving different possibilities. So this is the supply chain outlook, whereas here we are purely going to see the manufacturer's outlook, which I think is reasonable still in these days, but it is a little bit outdated with respect to perspective. Then why do I like this paper? Well, I like this paper because of the following reasons. Number one, they talk about strategic and tactical decisions in the same framework, which is not very frequently done, and you usually need to do that in order to assess your strategic decisions in a reasonable way. You have to be able to account for the operational costs. Okay, and this does that. And secondly, the approach that they take is very nice. They have a certain case in their mind. So this is actually something which is nice for the academicians to do. And they are confronted with a specific case. So they do some kind of an R&D project for a company. They solve the company's problem, but then they have a conceptual model. They develop a conceptual model. They validate that model using company's data. Now, validation of a model is something which is very difficult to do in general, but this is what we are expected to do as engineers if we use our engineering side. They validate that using data. In other words, they say that the model that we are using makes sense in this environment, and they have a lot of efforts to validate the model. And plus, they develop, the model that they develop is a very sensible model, and it is a new model for the sector so that they allow this to be published in a journal like Management Science. So what you have is you have everything realistic and at the same time a very general model that can be used and developed under different circumstances. So that's the reason why I like this paper. It's a complete report of a study which is done for a practical purpose, but at the same time, the authors were able to generalize that so that you have some kind of a contribution to the scientific world. Okay? So this is actually what is expected from an academician who has an engineering background. Okay? So this is one way of judging the value of the contribution. Anyway, so that was probably my sentimental reasons for including this paper in the course material. Now, the model that they use is very simple, and I'm going to write the model. The way that they solve is actually is very nice because they make a few observations and then they are able to solve the problem in a simple way. So now let me introduce you the notation in this problem and let's see how the problem is solved. Now, we have a number of different products, of course. We are not talking about a single product. So Z is going to stand for the index for products. And then we have a number of different variables. Now, V sub IZ is going to be retailer I purchase volume. Of course, this purchase volume is going to be the decision given by the retailer. Here in this model, we take this volume quantity somehow as given, although in an extension they say that we can handle it if this volume is going to be price dependent. Okay? In other words, I shouldn't say price dependent, but it depends on the profit that the retailer makes on this volume. Then you have P sub Z, which is the manufacturer's list price. So we're talking about a mature market where actions of a single manufacturer is not going to change the list price. Okay, so this is the way that you usually reason. In other words, if the price is affected by my decision as a single company, then it means that the sector is not a mature sector. The product is not a mature product. Okay, because I can still affect the demand by changing the price. But if it is a mature market, which means that there are enough number of competitors around, you as a single company, by making operational or even strategic decisions, are not going to change the price. So the commodity that we're talking about is a standard commodity in that respect. You don't have a lot of different versions or other things related to that. Okay, so this is the list price, and K sub Z is defined as the direct unit cost of manufacturing. So you can see that we are assuming a very simple structure. We are assuming only variable costs. D sub Z is the wholesaler's trade discount. So here what they do is they define this trade discount in terms of Z's. Okay? So it means that the trade discount is not given to the volume. Contrary to practice, it is given to different products. Okay? But in practice, actually, this trade discount is given to the whole volume. But the way that they are going to implement this discount schemes is such that it doesn't matter whether you apply it to item or because they are going to take it uniform across the products. But this is probably not something which is very realistic. As I said, it is given directly to the total volume. Now, C sub I J Z is defined as the manufacturer's marketing and sales cost when selling to I, we use, or selling to I through J. Now, J can be, of course, either M. If J is equal to M, then we're talking about direct shipment. Otherwise, we're talking about the wholesaler, which is sort of the closest. Okay? So, of course, the retailer is only going to select CIJZ with whom it is making all the trade. Okay, so if it is directly relating herself to the manufacturer, J will be M, otherwise J will be the wholesaler who is going to work with that retailer. Okay, so note that manufacturer still has some kind of a marketing and sales cost. What is this cost? Well, the manufacturer has to market it either to the wholesaler or to the retailer, and persuasion and going there is going to be this is going to be the expenses which are paid per unit by the manufacturer. Okay, and then finally I'm going to have R sub Z, which is the rebate that I'm going to offer to a retailer. So now I know that the retailer is using the wholesaler, but now I want the retailer to directly buy from the manufacturer. So the manufacturer is going to give a rebate to the retailer for switching. So switching in this case means that the retailer is going to switch from the wholesaler to the manufacturer. Or let's say to induce. I think it might be better if I write to induce switching. If we want to induce switching, we are going to give this rebate. So note that if you give higher R sub Z, the retailer will be more willing to switch from the wholesaler to the manufacturer. Okay, of course the way that we are going to have this R sub Z's is that we are not going to have different R sub Z's for different items, but we are going to have some kind of a uniform R sub Z for all items, so that if there is switching going on, the retailer is going to switch over all products. So the retailer is either going to use the manufacturer for everything or the wholesaler for everything, which is reasonable actually. Because if you start doing half and half, then it's not something that is usually asked for. As I told you before, usually manufacturer thinks about these rebates or trade discounts over the volume rather than over single items. Okay? So this is a decision variable, of course. Now this is one of the decision variables. This is the key decision variable for the manufacturer. So now we can write manufacturer's profit. Okay. So let's say that you see there is nothing which is stochastic here. Everything is deterministic, but of course, we're talking about long runs. So this V sub IZ is the purchase volume that we expect during the year. Okay. Now, let's write manufacturer's profit. Now, of course, manufacturer's profit will be twofold. If manufacturer sells through the wholesaler, it will be a different profit. If it sells through directly, it will be a different profit. So I will define pi ij as the manufacturer's profit if all the sales is done through a wholesaler J. Okay, so if it is through wholesaler J, then the profit is going to be the following. We sum over all Z's, the following quantity. We have V sub IZ times. Now, what will be the profit per unit that the manufacturer is going to get? Well, manufacturer is going to sell it to PZ. However, there will be a direct cost, which is K sub Z. And then we have D sub Z, which is the discount, trade discount given. So this is going to be over the volume. And at the top of that, we are going to have the sales expenses. So this is not per unit, of course, because it is done in a total manner. So you see that actually here This is going to be summed over all z's, and then the rest is going to be a function of I and j. So, of course, if the manufacturer sells it through a certain j or through the other j, is not in the decision of the manufacturer, but it is basically in the decision of the retailer. In other words, retailer selects the wholesaler, of course, and accordingly, the manufacturer is going to make some profit. But of course, the manufacturer always has the has to pay this money, because basically this is the money that you spend for the channel. If the channel is through J, you pay this C, I, J, Z for each unit. Of course, to write this on per unit basis is not very easy. Even if you look at the balance sheets and so on, it's not easy to get this quantity in practice, but they had a very nice way of getting these quantities in the case that they sold. Okay. Now, what happens if it sells directly? Then still we are going to have the same Z. And again, we are going to have V sub IZ, volume, times, again we have P sub Z, but instead of K sub Z, we are going to have R sub Z, which is the rebate that we give. But at the top of that, well, excuse me, what was K sub Z? Okay, this K sub C is direct cost of manufacturing. It's still there, I'm sorry. But instead of D sub Z, we are going to have R sub Z. And minus, now I'm going to have C sub I M Z. M standing for directly using the manufacturer as the supplier. Now, one other thing which is important, of course, is to understand that this is the current way of operation for the retailer. So in order to make sure that the retailer is going to switch, we are going to give some kind of a rebate. Okay? But however, what happens if you look at the problem from the retailer side? If you look at the problem from the retailer side, I am ready to switch when? Well, the rebate offer, which is an additional money which is flowing to me, is going to compensate for a certain cost. And what's that cost? That cost is basically, I know that if instead of using the wholesaler, if I use the manufacturer, my lead times are going to be longer. I'm going to receive a worse service, because basically I will be fed through very long lead times, and hence I have to keep more stock. So this is going to cost me something which is additional, and it is going to be something additional in terms as if like I am paying a more unit cost. So what then this RZ should do is simply RZ should be able to cover my expenses. So first I have to define what that expenses is. And let's say that I define S sub IZ as the, I'm going to call this as the switching cost. You only incur this cost if you switch from your wholesaler or from the wholesaler to directly to manufacturing. And let's say that this is the cost related to late deliveries, longer lead times, etc. Of course, this is going to be per unit. So you can say that your unit cost is going to increase, let's say by 10%, 20% because of this. Because you are now using a supplier which is far away, so you want at least the supplier to give you a discount, a sufficient discount, so that you can do this. Okay, any questions on this? Okay, so this number one specifies the switching cost. Now, how am I going to use this switching cost as a retailer? So a retailer does the following. I am going to compute sum of C This is the volume that I have, V sub IZ. And I am going to multiply this with the switching cost that I'm going to incur if I switch from my current wholesaler to the manufacturer. So this is going to be the total cost that I am going to incur if I switch. So total additional cost of switching. This is for the retailer, of course. Don't forget, manufacturer has nothing to do with this. Now, of course, if this amount should be compared with the total rebate value, which is given by the manufacturer. So on the other side, I'm going to have V sub IZ times R sub Z, which is the total additional value which is given to the retailer if switching occurs. This is the rebate given per unit, and this is the volume. So this is the total benefit coming to retailer if she switches. So for retailer, the decision is not very difficult. If this money is greater than the cost, then we're going to have switching. Okay, so if this is greater, then this is called the switching condition. Now you can see that if you give more rebate, the retailer is going to be more willing to switch. I mean, you can see it from here. If RZ for all Z increases, then this right-hand side is going to be larger. On the other hand, there will be some remote retailers who is not going to like this, because think about the fact that if the lead time, for example, increases from 1 week to 6 weeks because you are switching, then of course these costs are going to be very high. So any reasonable rebate is not going to satisfy that. So they are still going to be using the wholesaler. Okay, any questions on this? So this is the condition for the retailer to switch. Now at this point, okay, I can rewrite the problem in the following way. Let me define K sub I to be equal to 1. And if we have direct shipment from the manufacturer to the wholesaler, to the retailer, excuse me. Otherwise, we are going to use the wholesaler in between. Now I can write the total profit of the manufacturer in terms of these K sub I's. So what is the objective of the manufacturer? So let me write manufacturer here. Now this is basically what I am writing for the manufacturer. I am going to sum over all costs over I and Z. I will have double summation. Now I'm going to have V sub IZ, okay, times PZ minus K sub Z minus D sub Z, okay, and then I'm going to have minus C sub I J Z. Now this is the cost if I do not switch. So I'm going to multiply this with 1 minus Ki. Okay? In other words, if Ki is equal to 1, for that specific I, this is going to be 0. Otherwise, it will be 1. Note that Ki's are not decision variables directly. Ki's are a function of the rebate that you give, and accordingly, the retailers are going to make that decision. Okay, if you give a large rebate, some of the KIs will be 1, the others will be 0. If you make it even larger, the number of KIs will increase, which are equal to 1, of course. Okay, so this is one part, and then we have summation again over all IZ, and let me write this here. So we have plus summation over all IZ. This time I'm going to have VIZ PZ minus KZ minus RZ minus CIMZ, and this is going to be multiplied with KI. Now this is actually my objective function, and I would like, of course, to maximize my profit. What is my decision variable? My decision variable is simply R sub Z. Of course, I have to write constraints in order to qualify this condition. Remember, what is the condition that I have? This Ki is going to be 1 if this is satisfied for a retailer, for retailer I. Otherwise, Ki is going to be 0. Okay, any questions on this? Okay. Excuse me? We are going to maximize this over R sub Z's. In other words, this is the total profit that we are going to receive as the manufacturer. We want this to be maximized, and the only decision variable that we have is the rebate quantity. The DZ is already given. It's already decided. The KI is, we know that is going to be a function of the RI that we give. Now, I'm going to write two constraints, which is going to give that condition. But this is what we want to maximize. Okay. Okay, now this is, okay. Oh, I see. Now, I am assuming that, okay, the retailer has already selected a certain wholesaler to operate with. So the J is known. So you can say that there is a single wholesaler. It boils down to that. And it is going to be different for all J's, but we have only one wholesaler. So I could have replaced this with W, and this would be M, and that would be a recognized wholesaler. Okay? There are going to be more than one wholesaler, but of course, each retailer is going to select the one which is closest. Okay? So if you don't have any capacity constraints, this is not going to create any problems. And that will be something that we are going to discuss later on, actually. Okay. So although this is a subscript, but it is well defined for each I. So there is one-to-one correspondence with a certain J. So you don't need to write overall J's, because there is a single J that gives this C sub ij value, ijz value. Okay, how am I going to write the constraints? Well, I'm simply going to write that condition, summation over all Z, R sub Z, V sub I, Z, minus summation over all Z, S sub I, Z, V sub I, Z, this times Ki minus 1 should always be greater than or equal to 0. So what this means is that, okay, now this is sort of the constraint. Now I know that if the cost is going to be more than the benefit that it brings, this part is always going to be negative for those RZ values. Okay? So in order to compensate that, Ki, excuse me, if this part, let me see. Okay, let me write the other constraint and explain both of them so that in the meantime I'll think about it. Okay, so we have summation Z, R, Z, V, I, Z minus summation SIZ VIZ multiplied by KI should be non-negative. Okay. Okay, yeah. Now Ki is going to take a value of 0 or 1. And you see that, again, if the cost is more, okay, we are not going to have switching occurring. So Ki will take a value of 0. So everything will be multiplied by -1, and this condition is going to be satisfied. Okay? In other words, if this part is negative, you have to have Ki equal to 0. Well, okay, if it is 1, of course you can see that whole thing is going to be 0. And so in that respect, this is not a very typical constraint as if it works in linear programming. I understand that. I figured that out now. But the expectation is the following. If you have this negative, I'm going to set Ki equal to 0, okay, so that this is going to be always positive. And on the other hand, if this is positive, I'm going to select Ki equal to 1, so that this condition is satisfied. Now here, of course, you want both conditions to be satisfied at the same time. So what happens is that if you set Ki equal to 0 in that case, when this is negative, okay, and then you are not going to have this binding. Whereas if you set K equal to 1 here, okay, and then this is going to make it 1, but this is going to be violated. So you see that when you have both of them, it is going to work such that Ki will always take a value of 1 if this is positive, and Ki will always take a value of 0 if this is negative. Okay? So the constraints actually work perfectly if you consider both of them at the same time. Yeah, but in the objective function, you don't have the switching cost coming into picture, because the switching cost is the cost which is paid by the retailer. We only have the RZs in the objective function. We don't have the switching cost. So basically, the objective function is decided after the retailer's decision, whether they are going to use the manufacturer for direct shipment or for the wholesaler. But the solution, the way that the problem is solved, when you see that, we will see that actually it is solved in a very reasonable way. Okay, so this is more or less the problem. Of course, you can rewrite this equation in such a way that you have certain components which are functions of Ki, and you have components which are independent of Ki. And you can always actually write that. If you look at equation 9 in the paper, the first term is going to be independent of our decisions. The second term is dependent, the second and the third term is dependent on our decisions, and the fourth term is also independent of our decisions. Okay? In other words, the manufacturing cost doesn't come into picture. You can see that, because whether this way or that way, you are always going to pay your manufacturing cost if you want to satisfy the demand. So equation 9 actually rewrites this objective function so that you have the constant parts out. Okay? Now, when you look at the remaining parts, the solution turns out to be quite straightforward. So let me talk about the solution. Now, this looks as if this is a nonlinear program, because you have Ki's multiplied with RZs. Both of them are decision variables. Well, decision variables, but Ki is not the decision of the manufacturer, but it's a consequence variable. But still it is unknown. I mean, we don't know what the value of Ki is. So the solution of this problem is not very straightforward unless you make some simplifying assumptions. So now we are going to see a couple of simplifying assumptions. And these are the assumptions which are validated from practice. And we see that R sub z is going to be selected, is going to be uniform for all products. So it will be a percentage of the price, which is P sub z. So that percentage is going to be across the board. So this means that the manufacturer is going to tell the retailer that regardless of the item that you buy, if I'm going to give 5% of my selling price to you, back to you as rebate. Okay? So that percentage is going to be uniform over all products. So this is basically a very reasonable assumption. I would, if I were to start this problem, I would define RZ from the beginning this way, because you are not expected to have different R sub z's for different products in general. Usually what happens in practice is that you have some leading products, you set certain R of z's accordingly, and then you give the same R of z to the other products as well. So this is the way that it works in practice. As I said, the manufacturer is concerned about the total rather than the parts. And similarly, S sub IZs, which are difficult to determine, we are assuming that they will be uniform for all products. In other words, there is this assumption that when I want to determine the S sub, the switching cost for a retailer per unit, it will be a certain percentage of the price. So this is the way that everything is considered. Now, any questions up to this point? Now, how are we going to solve this problem? Now, one observation is sufficient probably to solve this problem. This is the objective function, and we have two constraints. Well, I think I skipped one of the boards. It's like skipping pages. These are the constraints. I should have written over here, actually, but I started to write over there. So we have those constraints here, and then we have the objective function. Now, what did we write here? We said that R of z is uniform. So what does this mean? Consider retailers. There will be a group of retailers, and for some retailers, the switching cost is going to be, or the multiplication of the switching cost with volume is going to be different than the others. But you see that if you start giving a certain percentage here, a given percentage for all items, it means that you can take this R out, okay? Then what happens is that if the R that you give, which is a percentage, is larger than the percentage of SIZ, okay, then this retailer is going to switch. Remember, we said that S sub IZ and R sub Z's are simply defined as percentages, and they are uniform. So as long as they are uniform, let's say that S sub IZ is 20%. What does this mean? It means that if I am going to switch, all my costs are going to increase by 20%. So if you give a rebate which is at least 20%, I'm ready to switch. Okay, so this is actually the meaning. So what happens is that then for every I can define a term which is called phi I. So let me give the definition of phi I. Phi I will be simply SIZ times VIZ divided by summed over all Z divided by PZ, which is the price, times VIZ. Okay. So what is this phi I? Phi I is a term which simply describes, it is basically the switching costs that you pay divided by total value of the items that you sell. Okay? So now you can see that I am going to add an RZ here, which is going to be a percentage. So if the denominator is larger than the numerator, then I will be expecting the retailer to switch. So these phi i's are called switching numbers. Now, the larger phi I is, the more difficult the retailer is going to switch. Okay? So what you can see is, you can see that now I can simply order the items, the retailers in such a way that I am going to have this satisfied. Okay? So I am ordering retailers in such a way that the larger the phi I value is, I'm putting it to the first place. Now what happens is that, now if I give more rebate, this list is going to be instrumental for finding out which retailers are going to switch. So if I give more rebate, I will have more included coming from here. I will have more of them included in direct shipment. So you can see that as long as I switch, I increase my R value, I will have an additional phi, an additional retailer coming into picture. And I can find out which retailer is going to be switching to me if I increase one more unit, the rebate that I give. So in this way, the algorithm becomes very simple. If you write the rebates as percentages of the price, so you search for RZs, which are going to be 1%, 2%, 3%, or you can make it more precise, of course. Okay? Now, for each R, you can find out which ones are going to switch, and then you compute your objective function value. Very simple evaluation, actually. So at some point in time, you are going to see that the cost of increasing the rebate is going to start hurting you. So you're going to have probably a very nice concave function. Okay? And then you're going to find the rebate that will optimize your profit. Even if it's not a concave function, well, it is going to be a concave function. Everything is linear here. So if there is this point here that you can differentiate the retailers, then you're going to have a concave function. Of course, the problem that they are interested is not that simple. They have some restrictions. So there are some other constraints that I didn't mention, but I think you can read it from the text. Those are the constraints which make things reasonable. For example, they don't want to allow for a very large rebate. And this is basically, they don't want the wholesalers to be sort of unsatisfied with this change. They want to limit the number of retailers that are going to switch because they have a fleet. There is a certain fleet which carries directly from the manufacturer to the retailers, and they want to restrict the number because the fleet size is sort of limited, so on and so forth. But the constraints are less important, but I think once you have this basic solution on hand, then you can obtain better solutions in a very nice way and solve the problem. So you see that although we have a highly difficult problem, there is a few abstractions which help this. One of them is this so-called S sub IZs. Now, with our current knowledge, we know how to compute S sub IZs because that will correspond to an increase in the safety stock that you keep. So what you have to do is you have to make that per unit you have to redefine the units of that additional safety stock that you keep. It will be basically in terms of the number of units that you sell. So you're going to assign a certain percentage. And that's the way that they are estimating those values. Now, you see that this whole thing is what we have been doing in the beginning of the semester. Everything is represented in a single parameter, actually. Okay? Because, I mean, you have highly stochastic structures and so on. You can resolve those. Similarly, constraints that you are going to add up is going to make the problem more realistic. Okay, so this is the extent that I want to talk about this paper. Any questions on this? So what are the things that are nice? Abstraction is pretty nice because although these are sort of certain variables, they all have loaded meanings, actually, because the way that you can compute them is not that simple. Moreover, the solution strategy is quite nice, actually. Okay. Any questions or comments? Okay, again, next week we are not going to have any lectures, so I'll see you on Tuesday at 5:40 in EA 322 for the exam. Okay.